Good afternoon, everyone. Thank you for joining our AI town hall on the topic of infrastructure. Let's start with land acknowledgement. The University of Washington acknowledges the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Duwamish, Puyallup, Squamish, Tulalip, and the Muckleshoot nations. So today's town hall is hosted by Xiaosong, Professor Associate Dean for Research, College of Art and Science, and myself, Bingo, and I'm the Associate Vice President of Infrastructure and CTO for UW-IT. Xiaosong and I are also the co-chairs of the Infrastructure Working Group in the AI Task Force. We have 5 panelists joining us in this discussion today who will have the opportunities to introduce themselves when we enter our conversation. Before we start the panel discussion, Xiaosong and I would like to go through a few slides just to set a bit of the context. This is a quick recap of the AI task force. On the left side of the slide, you see the structure of the AI task force charged by Provost early this year, and the infrastructure is one of the 5 working groups. And on the right side, you see the list of working group members who came from different parts of the university who contributed diligently to our formulation of our recommendations. And Xiaosong and I would like to take the opportunity to thank them for their active participation and contribution to the infrastructure working group. In our group effort, we have looked at many areas, including the cyber infrastructure and the supports needed around it. We also touch on a few topics like governance, IP, data privacy, security, industry relations, etc. We had a lot of good discussions and ideas. However, we have distilled the recommendations to the university to a few key proposals, which are incorporated in the first task force report that was shared on the provost blog. At high level, we, as infrastructure working group, we recommend the university to develop a scalable computational infrastructure essential for all users of AI. So this includes 3 key elements. The first, that we recommend the university to invest in increasing the capacity and lower the barrier of the existing computational infrastructure, which is our higher supercomputer. And Xiaosong will cover a little bit later. Second, we recommend the university to invest in the next generation data center and also the state-of-the-art computational infrastructure, including GPUs, networking, storage solutions, so that when our researchers and faculties need the capacity to do their work, it is there and ready. And the third element, we recommend the university to provide secure and scalable access to some of the AI tools and frameworks. In today's conversation, due to the time limit, we will focus our conversation around the first 2 points here. And if we have time, we can address number 3 as well. Now I'm going to hand over to Xiaosong to take us through our existing capability and kick us start with our panel discussions.
All right, next slide. Good afternoon. I'm Xiaosong Li. Currently, I'm the Associate Dean for Research in College of Arts and Sciences. When I started working on the AI Task Force, I was the Associate Vice Provost for Research Cyber Infrastructure on OR. Then work continues after I moved from OR to the college. I'd like to give you a little bit of background about what we have at University Central. Of course, everyone knows HIAC supercomputer. This is a current generation is a clone, the 3rd generation, commissioned in March 2021. It's managed by a group of very talented engineers led by Xiaosong and Nan Fu. They are just some of the best system engineer in the world. So it's very well managed. Right now we use shared condo model, and I think and you can ask me more questions about what this model is, but I just want to give you a little bit background. There's a history of why we use shared condo model. I think it's because if you charge your equipment to your grant, if you charge it as a facility and equipment, you can get indirect cost waiver. So the condo model is actually a perfect model for that type of effort. Going forward, that will be different models, and I will talk about it later on. So right now, this supercomputer Hayek is housed in UW Tower data center. So it draws a 1.8 megawatt. It's not in a big supercomputer, but it's a very highly usable supercomputer. The downtime compared to other supercomputer is very small. It's a great facility supporting almost 2,000 researchers. Right now we have 30,000 cores. We have 700 GPUs. We have different type of GPUs from A100, A40, and L40, L40S, and there'll be some H100 coming online in the near future. And those are GPUs owned by individual groups, but because the condo model has a really neat shared backfill queue, so basically you can, if the GPUs and CPU cores are not being used, you can actually submit job to use all this CPU GPU cores from other groups. So that's actually a very important aspect of the Hayek model. So you can take a look at the current network, and it's good, but not not state of art. Next slide. So there are a lot of recommendations after the campus-wide survey, and these are a few bullet points. I think we draw a moderate to great level of support. So, but I would like everyone to think about this broadly. Every bullet point actually has many details in it. So don't just read the headline and think about what's underneath it. For example, in the first one, we're going to add 1,000 specialized GPUs. Right now, we're not talking about adding that in day one, and this is going to be a long-term investment, and that's the goal. The goal is to be on the cutting edge instead of the bleeding edge, and that's very important because we're not going to, we don't recommend it to invest a lot of money without the strong community support, without a well-established well-established usage on campus. So there's going to be a stepwise investment towards 1,000 GPUs, and this could be revised in the future as the new GPUs become more powerful, more compute intense. So this is just based on current trajectory, and 1,000 GPU is one of the recommendations. Of course, AI and in general machine learning require fast data access and egress, and so improving data storage and connection is very important to handle AI needs. In fact, handle any type of big data research, and from astronomy to biology to biomedical research. And there are definitely the discussion about why we don't use cloud. And we did an extensive analysis about the cost of cloud versus the on-premise computing, factoring out support, the resources we have to put in to support this on-premise computing. I can tell you that if you use cloud, it's still a lot more expensive. I'm not just talking about 2 or 3 times. I think multiple research teams have done their own calculation. We did our own calculation. Luki from IPD did their calculation. Actually, we converged to the same kind of agreement that it's very expensive to use cloud, especially for the cutting edge GPU resources. Power is a big concern. Being in Seattle is blessed and curse. We can draw the top talent, but on the other hand, we're limited by the power we can use. So tower is the two data center in a tower has limited power supply. So that is a big concern. Even if we want to expand Hayek, and we have to think about how we're going to support the future the power, increase the power. But in GPU computing is an opportunity. When we talk about power, we do have to think about environment in general, because we don't want to just grow the computing facility without considering the impact of the computing on the environment. GPU present a unique opportunity because it's high density in terms of computing power per watts, and GPU is actually a more green, more efficient. So we have to, the whole team have to think about how to optimize the computing and the power ratio. So this is a pretty big discussion, and we need a whole community to contribute their wisdom. There are ways, as I mentioned, that Kondo model is a great model based on the current grant contract situation. But going forward, we need other models, because we need to support education, research, and we need to support people who wants to try it out, who want to just to test out how AI can help their research and education. So we need a different model. So we don't know what model is going to be most efficient, but I think the team, IT, OR, and the college are all working together to create a sustainable model that it's not only affordable, but also create opportunity for anyone who is interested in doing AI. Next slide. So with that, we're going to open panel discussions. We have prepared a number of questions to our panel, and you can see we have 5 panelists. They represent IT side of AI infrastructure, to research side of AI application, and to management side of an computing facility. So and network. So from that, so we're going to start from we're going to start a question, and I'm going to ask the panelists to introduce themselves when they answer the first question. All right. So the first question, I think, is pretty much the same question in everybody's mind. What are you most excited about AI? What are you most worried about AI? So I will start by calling out Aaron Timms to answer this question.
Hey, good afternoon. My name is Aaron Timms. I'm IT Director for Computer Science and Engineering here on the Seattle campus. I just want to say thank you to the task force leadership for including me and inviting me here today to talk. To the question, I'm most excited about all the research in AI, both experimentation and applied science that is already happening here at the university. We are certainly not behind the ball on research. As for concerns and challenges, from an IT perspective, it is the realization that AI is going to become quietly or not so quietly embedded in these vendor productivity tools and information systems that we rely on every day. This is where the market's going. This is where the world is going. The challenge for IT and for all of us really is to understand the risks, impacts of that subtle change to the university's missions and our work, and design for and promote responsible use of these enhanced tools. Thank you.
Thank you, Aaron. Shijing.
Hi everyone, I'm Shijing Song. I'm assistant professor from mechanical engineering in College of Engineering. Thank you very much for having me here as a panelist. So my own research involves using AI for advancing clean energy. I also teach in AI for clean energy. So that gives me kind of a perspective to share about my excitement about AI. So what excites me the most is definitely the transformative potential of AI for scientific discoveries. So it offers new tools for us to tackle the critical global challenges such as climate change, sustainability, and health. We really expect AI to significantly drive innovations across industries over the next decade, from manufacturing to transportation to aviation. There's a lot of potential. I guess the concern I would have at the moment is how do we ensure proper and timely education to train our next generation engineers and the researchers on AI, because teaching people how to responsibly and effectively integrating AI into their own work is essential to maximize the impact of AI.
Thank you, Shijing. Luki, you're next.
Yes, hi, my name is Luki Goldschmidt. I'm in charge of the computational infrastructure at the IPD. That's the Institute for Protein Design in the Department of Biochemistry, School of Medicine. And I'm excited about how AI-driven approaches are rapidly transforming our work in life sciences. We've seen projects taking entire PhDs to be tackled by rotation students in a single quarter, starting from in silico work all the way to real life lab results. And it's kind of an AI revolution that's happening right now. It's very fun to see. I'm slightly worried about equal access. I mean, that technology is expensive to use in terms of equipment and the use. So hopefully everyone gets a chance to use it, and we can retain talent so we don't lose all the good people from academia. They go to industry, and things get developed in a closed environment.
Thank you, Luki. Dave.
Hey, good morning. Thanks. My name is Dave O'Mara. I work for UWIT in the networking department. I'm the director responsible for network design and architecture. The things I'm most excited about are the new use cases that we haven't discovered yet. In the last couple of years, we watched the game of Go getting solved. We watched protein folding getting solved. We solved language. We solved image recognition. Those have been amazing. I'm a physics geek. I am very much like Luki, looking forward to what AI is going to help discover in physics. And I love what David Baker and the team and the protein folding and protein design, the concept of protein design to me is absolutely fascinating. What I'm worried about is currently solving what are known as hallucinations. I think having software that is entirely probabilistic needs to evolve if we're going to allow it to control things. If I'm thinking about factory control or software taking actions, I think a hallucination would be a bad thing. I think also there's a lot of talk about intelligence, like it's artificial intelligence. So I decided to ask ChatGPT what it thought. And it said, large language models are a highly advanced pattern matching machines. They can simulate reasoning by identifying patterns that correspond to correct solutions, but they lack any actual conceptual framework, mental imagery, or self-awareness that humans rely on for true understanding. So we can solve hallucinations, solve understanding. Yes.
Thanks, Dave. I learned something new about you. Xiao.
Yeah, thanks everyone. My name is Xiaosong, and I'm an Associate Vice President for Research Computing at the UWIT. And as trained as a chemist, I can see how AI have changed, the research and even probably daily life. And I think we are all excited about what's the future of AI. And I think at my current role, I would like to support to provide the AI platforms and the tools, frameworks to the research across the campus. And my biggest concern is how it is what's the probably a responsible use of AI. And this is going to be some topic we're not going to visit it today, but this is something I think we should discuss in the community. And yeah, I will stop here.
Thank you. Well, now I think we all, every panelist has a chance to introduce themselves and their thoughts about AI in general. In my own point of view, in AI without impact is not, that interesting. So we always talk about, how a new technology can make impact either in research, education, or, in improving our health in general. So I'm going to dive into another question. This question is definitely related to our current hot topic at Timss Washington, our biggest Nobel Prize. How will integrating AI into research at UW lead to a novel solution for pressing scientific challenges and opportunities, such as the work that led to the recent Nobel Prize awarded to Professor David Baker for his pioneer work in protein science. I know in Institute for Protein Design, Luki plays an essential role in supporting the protein design effort using computer-aided simulation and AI. So I'm going to ask Luki to jump in to answer this question.
Yeah, okay. So at the IPD, we have lots of talented scientists who developed new tools for everyone to use. Our goal is to make them available to everyone in the world, not lock them down. So the code gets released, the training waits, once it's trained, will get released, and once the paper is out. We scientists develop new machine learning network architectures, train those networks on large data sets. That's a computationally expensive step. obviously, that shouldn't be repeated necessarily. And then those models can be used in inference to come up with new computation solutions to like real life problems. One of such example is RF diffusion. That's a powerful deep learning program that generates new protein structures in a manner similar to like DALL-E that generates images. Other tools in protein design have enhanced our ability to create molecules, with advanced functions like experimental vaccines, medicines, nanoparticles. So it's really a wide palette of applications that are enabled by these new AI methods. I feel like there is so many projects in the lab. It's hard to keep track of what people do, but it's exciting to see, the wide spectrum. And I want to highlight that the cool thing is that most of the powerful and popular AI-based tools are actually made right here at UW. So we're pretty much on the edge of the frontier, and yeah, we want to make them open.
Luki, can I ask you to tell us more about the infrastructure you have at IPD?
Yeah, so we have, what is it these days? Roughly 1,500 GPUs. They're not all high-end GPUs for training. Probably a third is for training, the rest is for inference, since we have lots of scientists who actually use those tools to come up with new solutions and then test them in the lab. So we need both. There's a small team of maybe a dozen people who actually do like our hardcore machine learning experts who are very good at what they do, and they need resources, right? For example, training a Rosetta fold from scratch takes about 2 weeks on 100 or 200 GPUs, so it's a commitment. We have some of it is on campus, some of it is off campus, simply because there's no space on campus. We did try use a cloud, but as was said before, it is expensive. It's not always easily accessible because of the high-end GPUs are in demand by everyone else. So to us, it was not a good fit. And if right now, actually, ironically enough, we're doing a bunch of training grants in Sweden, where I was last week, because Microsoft has no GPUs left for us in the US. So we transferred 20 terabytes of data to Sweden, train the stuff there, and yeah, so there's issues.
Well, thank you for sharing the information. Well, I'm going to ask Shijing to provide us additional viewpoint from mechanical engineering side.
Yeah, sure. There's definitely a huge potential, a lot of excitement about like integrating AI into the research from the mechanical engineering, or even just like in general, the College of Engineering, and also across the campus at UW. So 2 aspects I think it's worth noticing. One is like we use AI for improve the research productivity. So it speaks to the infrastructure we have, allows us to like automate data visualization, data analysis. So a lot of the students now can like automate some of the tasks in their research using AI. The second aspect is definitely the idea of the intelligence, where like now we have the AI scientist as a seed concept, where AI is starting to act more like a lab mate for our researchers and students, where we start to use the AI to generate innovative solutions. With that said, that also speaks to the infrastructure we have here in UW, allow us to train machine learning models at a high speed and also high performance. So in the field of clean energy, where my group works a lot on, we've seen AI has been integrated into the research here at UW in battery research, in renewable energy development, and also in quantum science. So all these areas benefit from the speed and the scalability AI infrastructure is able to provide. So a lot of the challenges here in terms of the scientific challenges often comes from the computability and also come from the large parameter space when scientists and engineers are trying to solve a research challenge. So for example, material discovery and also drug discovery, it's simply just not possible to really test all the hypothetical molecules and materials composition in the lab. So here we use AI coupled with robotics to help us to accelerate the shortlisting of the candidates that are worth to be tested in the laboratory. So this is kind of one of the examples how we can leverage AI to help us accelerate the scientific discoveries and the research, and that would lead to a lot of potential impact across disciplines.
Thank you so much. Thank you for sharing your perspective on this. There are a lot of arguments about one of the arguments to about investing in AI infrastructure is to attract and retain talents. So regarding to this particular question, whether or not investing in AI will be critical for talent attraction and retention attraction. So I would like to ask Aaron to chime in to share with us some of his thoughts on that.
Yes, and to the question, yes, absolutely. We have nationally recognized and recruited faculty in computer science and engineering. Some of these folks have, industry appointments who are willing to stay here at the UW part-time, at least keep one foot, one leg at UW to benefit our research and our teaching because of access to these resources. So some have access to sort of hyperscale environments in their other job, but they want to replicate and leverage those successes and those experiences here at UW and using resources here to benefit the students and their personal research. During faculty recruiting, I often meet with candidates right up front to tout HIAC's capabilities and other computing resources that we have because they're asking those questions like, what can UW provide? It's really become critical enticement and part of the offer package in many cases. Thanks.
Oh, great to know. How about you, Luki? About IPD?
Well, I mean, I can echo what Aaron said. Absolutely, we need those resources, right, to attract talent and also to keep talent around. I mean, some of this AI hype probably will die down, but the transformation is real, right? So it's a good investment for the future, yeah.
Yeah, thank you. So we have HIAC, and I think IPD has their own big AI computing cluster, and I think many faculty have their own small cluster or desktop, to do different type of computational research. So what are the needs and gaps of the existing infrastructure you experienced or you heard from faculty, researchers, and doctors, physicians, and student work? So I'm going to ask Shijing since she's a research and educator, she must have heard a lot of things about it.
Yeah, so definitely the first thing I think a lot of us here have already recognized that there has been a rapidly growing need and interest in AI over the past few years. As a result, there's a rapidly growing request and demand for the AI infrastructure. And one thing I did notice is that a lot of the fields, maybe traditionally, they are not the fields that need a lot of computing resources, now have also joined us because AI has been used in their field. So for example, I've heard researchers and students from computational chemistry, from environmental science, and from of course here in mechanical engineering, there has been a rapid increase in the demand for computing resources. With that, I think that leads to the several key needs, as a community we need to address. The first one would be how do we lower the barrier of entry to our computer resources? So more of the people, especially people who didn't have a lot of background in high throughput and high performance computing, can join and also integrate AI in their research. A second need would be now the application of AI become much more diverse than a few years ago. That means there will be discussions on the use of AI from data visualization to model building to some of the software framework development. So we would like to have the resources to really satisfy the diverse needs from the researchers and students here in UW. And lastly, a need we've seen growing is definitely how do we integrate AI into the education here we have in the classroom. So in my course in the spring, when I was teaching AI, I benefit from the Jupyter Hub, where we have the everyone in the class get access to the Jupyter notebook through the Jupyter Hub that UW offers. And that actually turns out to be really good and really smooth, and we have a lot of positive feedback for integrating the infrastructure into the classroom teaching. So that's kind of exemplify the needs of having AI infrastructure in both research and education.
Thank you. Well, Aaron, I want to hear your thought on this. What's the gap and needs?
Sure thing. In a nutshell, demand exceeds supply for AI hardware model training from a broadening number of faculty, like Shijing said. Many workloads that we do are long-running, continual. The research is messy. As such, that again, they're not cloud optimized due to the high cost of longer-term instance reservations. In some cases, as Luki's already said, the cloud can be sold out or at least priced out and leading up to critical conference deadlines where we want to be competitive and we want to submit papers. So having access to these on-premises HPC facilities has really been a strategic hedge and enabler during these surge periods.
Thank you. Luki, I know IPD had a lot of challenges in infrastructure and getting the needed infrastructure. Can you share some of the perspectives?
Yeah, I think there's two key concepts, right, or aspects. I mean, one's access to resources, which we've discussed, but also access to expertise. A lot of these new tools are so rapidly being developed that new users are totally lost, hard to get started. And that's one thing we can address by some user training or maybe classes. And then there's also scaling to larger systems. Weird things happen like communication issues or GPUs are out of sync, whatever. So there's all kinds of weird things that happen when you run stuff at scale. So having that expertise, so you can have someone to ask questions. Usually people come to me. I'm not necessarily expert, but at least I'm trying to answer those questions. So that's what I've noticed, access to resources and access to expertise. Yeah, in terms of resources, like I said, we build that stuff offsite because the cloud it's not a silver bullet. It's sometimes harder to use than it seems. It's not as dynamic as it seems. And it's definitely way more expensive than people think between storage, data transfer, and access to resources. So I'm not sure that fully answers your question, but
I'm surprised, like Luki or Aaron, you didn't bring up the challenges with data center. So I was completely surprised. I was so sure that was part of your answer.
I mean, there is no space on campus, but we kind of know. So, well, yeah, hoping we can actually have all the equipment located here. It's so much more convenient than having to drive even 15 miles to somewhere. So,
yeah,
but we make it work.
Yeah, thank you. Well, we're going to transition towards more infrastructure-related questions, so I'm going to hand it over to Bing.
Yeah, that's a perfect segue into our next set of questions, right, for our panelists. So now we have heard a lot of exciting opportunities that AI can be used for our core activities on the campus. So I'm going to pose this question to Xiao and Dave both. So what is, from what you heard, right, with what we have right now and the gaps that the demand on the campus coming in, what is the strategy and the current thinking to enhance our existing infrastructure to support the initiatives across all the disciplines, right? And also, how do we make sure the underrepresented field, the need of underrepresented field are properly addressed as well?
Yeah, probably going to take a first step. And I think, University of Washington is committed to creating a cutting-edge GPU pool. And I think based on what the Xiaosong shared with the campus survey, we are going to design with a communal model to ensure equitable access for researchers and the students across campus. And also, in that communal GPU pool, we also would like to dedicate to a certain percentage of, computing and to teaching and for classroom instruction. And we believe that's important. And for the first phase of this GPU pool will involve deploying around 200 NVIDIA, GPU such as a Hopper, and we also, going to to make the GPU interconnection we're going to these GPU will be interconnected via the high-speed InfiniBand network. And also we mentioned earlier, for AI research, and you need a fast access for the data sets. So in this system, we also designed with about 3 petabytes of all-flash storage. And the current plan, the system will be housed in the existing campus data center with some small reconfigurations. And we believe, with this community shared model will foster collaboration optimize the resource utilization, and provides broad access to the computing capabilities. And looking towards the future, and I think the AI task force has recommended to invest about 1,000 state-of-art of the GPUs. And these GPU system will be likely hosted in AI-ready data center. As Xiaosong mentioned, this is big impact for the environment for computing infrastructure. So we want to have the AI-ready computing center with the advanced cooling, so we can draw less power, and as well as high power density. And in addition, these system will be coming with the strong security protocols. And in the future, we also in the setup will include a hybrid cloud design, so that we can offer flexibility and the scalability with bursting GPU and CPU capability. And we are currently, in active discussion and to find a strategic partnership with industry giant like NVIDIA to drive the development of this next generation of AI systems. And to make this all possible, University of Washington will also significantly increase the network bandwidth. And this will ensure the fast data transfer and the reliable access to these powerful systems, and to supporting the innovation across the university. And so I touched on the network at the end, so I will pass that to Dave to give more details on the network.
Thanks, Xiao. We've been working closely with Xiao here in UWIT over the course of this project. It's early days for sure, but we're closely involved in configuring the networking in the current data center in the tower where Hayek lives already. We're being very cautious to make sure that the new system and the old Hayek system can still talk to each other at high speed. Also, they're not isolated pools. We've also been planning for a lot of high capacity fiber around the campus. Once the data center is enabled with the new GPUs, we want to ensure that we have bandwidth and capacity to the campus, to the buildings on the campus, to transfer data in and out of the cluster. We have a loose plan for now to upgrade from the 100 gig generation of our core to a 400 gig generation of our core when funding becomes available. And we can increase the speed down to each building as well as necessary. Outside of the campus, we're working closely with Xiao when he's thinking about the external data centers where we might need to try to find 3 or 4 megawatts. We have a lot of fiber belonging to the university around the campus, and we have a lot of partnerships for fiber cabling around the lake and around the neighborhood. We have a ring known as C3, which can take us towards Bothell and Tacoma and down to the State Data Center in Olympia. So we have external high capacity fiber for the external data centers. Separately, we are already working on increasing the capacity to all of the clouds. We have private interconnect with AWS, with Google Cloud, and with Azure. We're working to build up redundancy across those connections, so it's not a single connection that goes down. They will each be redundant and each be connected at high speed. And for now, lastly, our Wi-Fi and cellular team, a colleague of mine, a peer of mine, Emil, is responsible for ensuring that we have great Wi-Fi and cellular coverage all across the campuses, Bothell, Tacoma, all of medicine. Again, just to enable infrastructure for use cases. It may be the client doing inference right out at the edge, right? We're putting chips into devices these days. So we are very conscious of creating an all-encompassing wireless network on campus as well. Those are all the notes I had, Xiao. Am I missing anything from our conversation, Xiao?
No, I think that's a pretty comprehensive.
Great. Thank you, Xiao and Dave. We talked about data center, right? And Xiaosong joked about that as well. So as we know, our current data center on the campus has limited capacity in terms of power and also the cooling, the type of cooling we can provide, right? So I'm going to pose this question back to Xiao and maybe inviting others to comment as well, right? What is our current thinking of assuming that we invest this 1,000 GPU computing state-of-the-art computing system? What are the thinking where we could house this AI system? And also, I guess, UW is one of the R1 universities. We have a lot of peers are also probably thinking about the same. So if you can share a bit of your view and what you have learned, what other universities are doing in this space, that would be great. So let's start with Xiao, please.
Thanks, B. And definitely, that's something, I think Xiaosong mentioned, that's a big constraint and in the Seattle area. And of course, when we talk to the community, it's not only our problem, it's actually the problem facing facing all the community, especially in the high ed, area. And I'm being mentioned some of the peers. We have peers looking at all different directions. For example, like Purdue University, they have been looking at to upgrade to their current data center, and I think their first phase will be cost probably about $16 million to upgrade. And on the other side, folks like Rutgers, and they are looking at the option to building the modular data center, and so that they can have a short lead time. And on the other side, on the West Coast, for example, University, like UC Berkeley, they are working with NASA and to use the data center from NASA to host their AI equipment. And same thing for University of Washington, and we are looking at the different options. And one of the options we are looking at is to have the collaboration with the Washington State Data Center. And so this is a possible collaboration. We can support the AI need for the whole state and possibly this region and for the Pacific Northwest. And at the state data center, they have plenty of power and the space available. On the other side, as I mentioned, for AI, to support AI-ready computing, to keep environment factor in mind, we need the investment to work with the state data center, require the investment to upgrade to make sure you can have the liquid cooling, so that make the computing more efficient, have the high density computing rack, and so that we can increase the computing and to reduce the time to moving data between the computings. And in addition, we are also looking at the possible potential other data center options. For example, co-location. And I think that's what the Luki has talking about, for IPD. So for the university, we're also looking at the different option in the Seattle area or the east side of the mountain, working with the vendors such as TierPoint and the SAB. And lastly, I think I mentioned earlier, we should also looking at in terms of a hybrid cloud and on-premise model, and to, how can we leverage and the resource available in cloud. And right now, the cloud is super busy and expensive. But is this the case will be continued to stay the same, or the situation will be improved? And so we definitely need to look at into the opportunity to be a hybrid model and to leverage the opportunity to burst into cloud, so that we can we can somehow to minimize the problem for the power need on premise. And I think that's my opinion, and I would like to ask Aaron or Luki to chime in.
Aaron, you or I? I mean, I'm just gonna say a couple of words. I mean, the next generation GPUs will be definitely more power hungry, so liquid cooling is probably gonna be a must, and a lot of colocation facilities are not set up for this, so that's kind of a concern, what I've seen. And I'm also interested to see that the cloud is both expensive and very busy. So like the money must be there in this kind of field, right? Otherwise, it would not be this very expensive. So that may change, but right now it's a hype.
Yeah, I would agree with all that. And, power density is a concern in any facility that we consider. So we need to be careful of that. I will just say on the positive side that we have computer scientists working hard at doing more with less in terms of leveraging older GPUs or doing more efficient workflows that sort of economize where you don't have access to the latest and greatest. So there's promise there.
Great. Any other panel members want to comment on this specific point? If not, let's transition our conversation to the Q&A from the audience, right? So we have a stream of questions coming, and let's start with the first one, which Xiaosong touched a bit in his introduction, right? So climate change. So the question is, how has the environmental impact of AI been considered in UW's plan for AI? I think Xiao, you touched base a little bit on that, right? So maybe reiterate a bit the points.
Yeah, I think, one of the thing I think Luki mentioned, the future, computing facility, computing device will going to use more power. And then there will be they enjoy more powers. And that means, we need to have more cooling capability. And with liquid cooling, we can, improve the utilization efficiency. And from, that can be improved by 30 to 40%. And by doing this deploy these advanced cooling capability, we're able to draw less power and to drive more compute. And I think that's what the direction we are definitely going for, and that's going to support more like a greener computing. And I think another thing is the power in terms of is in the future. Should we consider what kind of source of power? We consider any of renewable energy source, and that this is definitely something we keep in mind when we further explore and how can we power these AI really power hungry system, and how can we make that more environmental friendly. And other things, we could also, I think, we should consider what kind of, the renewable, these materials, how can we use that when we develop the data center, And so these are all probably approach we're looking at, evaluating, and I think you're most likely to employ. And but that's my comment. I don't know if any others have any other comments on that.
And also the heat recycling. So the heat generated from if we're going to design a new data center, and I think the heat generated from computing can be recycled, powered to power the building or to warm the building. So those are important consideration. The fact is our data center is really outdated. So right now it's not power efficient. It's not, to some extent, it's not. It's green, I think, but it's not up to not a state of art, environmental friendly data center. So we have a long way to go, and AI is an opportunity for us to consider the environmental footprint, the impact of our data center on the environment.
I think on a positive note is most of power in Washington State is fairly green. It's hydroelectric, right? So we shouldn't feel too bad about using. Sure, we should be conservative, but it's not like burning coal for this.
Another note I want to add is it's actually a research field in the AI research itself, the model building part. So we are also looking into a more energy and compute efficient AI models. So that also would help to achieve the energy efficiency in the direction we just discussed.
Excellent. And maybe just put a last point on that, which is tying to the other question came in, right? The duplicate infrastructure effort, multiple overlapping GPU infrastructure effort. So one of the way to make sure that we are efficient on the energy consumption is make sure that we leverage the infrastructure for different uses, right? Not to duplicate that. So definitely that's one area that we are looking into and collaborate on, making sure we develop the infrastructure and make the best use for all parties, right? And Xiao mentioned about the potential collaboration with state on addressing the state need. So that's one of the potential ways to make sure that we don't waste energy, right? There's another questions around the cost. We talked about the cost. I think Xiaosong covered a little bit as well. So the question is about interested in a bit more details, how the cost analysis build versus hyperscaler public cloud goes. And yeah, what are our thinking in terms of on-prem versus cloud, right? When it comes to cost.
So I can jump in a little bit. I think both Luki and Aaron also touched it in terms of the challenges to access cloud. But I think in terms of cost, there are multiple parties, including myself. Xiao also did this calculation. Luki did the calculation completely independent. So what we did, we include the personnel cost, or include the power cost, or even include if the cost if we have to rent the space. All these things are considered in the cost analysis, and it's very simple. You can do the calculation, and then you use Amazon AWS has the price. You even can include 10-15% discount if you are good at negotiating. It's very transparent. You can do the calculation, but we all reach the same kind of conclusion. Early this year, it was actually worse than right now. Now the price came down. Early this year, there was about we did a calculation about 8 to 9 times. I remember David Baker gave a talk, and his calculation probably from Luki as well, and it's about 7 times, right, if I remember correctly. So and right now it came down. Right now it came down. Last time we checked, it was Ting, the new associate vice provost of research cyber infrastructure. He did a calculation. It's rough. Right now it's about 4 to 5 times, but still a lot more expensive. This is just a cost. I'm not touching the challenge of accessing. So Luki, Aaron, Xiao, you want to chime in?
Just one data point. We got a couple quotes on renting a single high-end node, 8 GPUs or whatever, and it was basically a 1-year rental cost was equivalent of purchasing the hardware. So it pays for itself really quickly. Then of course there's all the other overhead, but yeah, that's just sort of one data point.
Yeah, for us it was like about 9 months, which is we could maybe discounted rates, but either way, we also simply ask AWS and Microsoft, hey, can we get a 1-to-7 match? And they did do that, but that's a one-time negotiations for a year and so on. So it's I agree, the prices they have come down. Yeah.
I want to probably approach the problem slightly differently. I think you always talk about the cost, several X of factor. But I think, when you get to the cloud access, you only get to the hardware, right? And we talk about also the expertise. I think Luki, Aaron, Shijing all mentioned. And here in the university, we're building the ecosystem of this ecosystem. So that's include the expertise, the support we can provide to the researchers, which could be maybe as expensive as the hardware if we really want to give a value of money. And so that's I think I want to add at this point.
Yeah, I totally agree. You still need the expertise. The stuff doesn't run itself. You just get the hardware. Yeah. So and that cost or for expertise stays if it's on site or in the cloud.
Yeah.
All right.
I also want to add a quick point here. The cost also comes with the long-term cost. So as a university, we have projects probably running for several years. And the data there, we want to store it for longer term, especially for a lot of the federal funded, state funded projects. So the cost of the long time, longer term, storage cost is also part of the consideration for having access to our own UW AI infrastructure.
Excellent. So we have 5 minutes left. I suggest that maybe we use the time to conclude. I know there's a lot more question coming in, and we can always adjust them offline. I would like to invite each panelist for quick closing thoughts before we conclude the town hall. So let's start with Luki, since you are on the number one on my screen.
Sure. Well, I'm excited that we're actually tackling this issue. We're not sleeping through this, and we're trying to stay on the frontier of this development. So that's great. I think we can make it happen. I would like the technology what gets developed to stay open and available to everyone, not just locked down in some kind of private company for profit company. So that's my drive to have it at the university, and yeah, I'm hopeful we're gonna make it work.
Cool. And Dave?
I would like to quote Bill Gates, the quote that I use a lot. Bill Gates said, we always overestimate what we can achieve in 2 years, and underestimate what we can achieve in 10 years. And with that said, ChatGPT says AGI will be here in 2 years. So I don't believe it. I look forward to building the infrastructure that lets the University of Washington write the next transformer paper. That's what I'm hoping for.
Excellent. And Shijing?
I want to say that infrastructure is really the foundation of a lot of the scientific and research innovations. It's easier to underestimate how much effort and also how much dedication this team here have put in. So I really want to say thank you for the AI task force for putting in the efforts in providing us with the advanced AI infrastructure. And my last sentence would be so as an educator, I'm very excited to integrate the AI infrastructure inside the classroom for our teaching and training of next generation researchers and engineers.
Great, thank you. And Aaron?
Yes, thank you. From my vantage over here in CSE, we've already proven the concept, that is the value and successes of having access to local shared HPC and AI infrastructure. HIAC has been an absolute game changer for us for a broad number of our faculty here. Like half of our research faculty are invested in using it. It's a shared resource that can scale well, given the right facility capacity. Personally, I think it's part of a strategic mix of research computing, and the UW should strongly consider investing in expanding facilities. Thanks.
Excellent. And Xiao?
I think I'm going to follow Aaron since I'm the business owner for HIAC. I think we are committed to, providing the support and the service, for AI and for the across the campus for both research and education purpose.
Oh, excellent. And Xiaosong, anything from you before we conclude?
Oh yeah, I'd like to add. I want to remind everyone that what we're doing here is using AI as a great opportunity to improve our cyber infrastructure. This covers not just computing, it will cover network, it will cover access, and this is a different cyber infrastructure support, not just research, but also administration and education. It's really broad. Where our cyber infrastructure is behind, is outdated, and to some extent, this is a great opportunity. So AI is an opportunity for us to get this done.
Excellent. And I want to also take the opportunity to thank all the panelists to make the time to join us, and for all the audience to join us for this session. You know who we are, and feel free to reach out if there's any questions that we didn't have time to address today. And with that, I also would like to thank all the support team to put this together. There's a lot of behind the scene preparation effort happening on this. And lastly, all the AI town hall materials are shared online, and feel free to review them. And again, any questions, feel free to reach out to all of us. And thank you all very much for your attention.
Thank you all. Happy holidays.
Yeah, happy holidays. Yeah.